We are told that the first 5 ionization energies for a third period element are shown below. What is the identity of the element? So pause this video and see if you can figure it out on your own, and it'll probably be handy to have a periodic table of elements. So before I even look at a periodic table of elements, let's make sure we understand what this table is telling us. This is telling us that if we start with a neutral atom of this mystery element, it would take 578 kilojoules per mole to remove that first electron, to turn that atom into an ion with a +1 positive charge. And then it would take another 1,817 kilojoules per mole to remove a second electron, so to make that ion even more positive. And then after that, it would take another 2,745 kilojoules per mole to remove the third electron. And then to remove the fourth electron, it takes a way larger amount of energy. It takes 11,578 kilojoules per mole. And then the fifth electron takes even more, 14,842 kilojoules per mole. And so for the first, second, and third, you do have an increase in ionization energy. But when you go to the fourth, the energy required to remove those is way higher. So to me, these look like you're removing valence electrons, and these look like you're removing core electrons. So one way to think about it is, let's look on our periodic table of elements and look for a third period element that has 3 valence electrons. So we have our periodic table of elements. We want a third period element, so it's going to be in this third row. And which of these has 3 valence electrons? Well, sodium has 1 valence electron, magnesium has 2 valence electrons, aluminum has 3 valence electrons. So one way to think about it is that first electron, it's a reasonable ionization energy. Then the second one a little higher, then the third a little bit higher than after that, but then the fourth, you're starting to go into the core. You're going to have to take an electron out of that full second energy shell, which takes a lot of energy. And so this is pretty clearly aluminum that is being described.